For this question, we want to solve the logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. The logarithmic equation that we're working with is 8 natural log of 2x equals 40. Before we begin solving this equation, I want to explore the methods for solving logarithmic equations that we're familiar with. The two methods that we use are converting to an exponential equation and the one-to-one property of logarithms. And sometimes this is referred to as the property of equality. If we look at these two methods, let's take a look at the requirements. The first method requires the logarithm to be isolated on one side of the equation, as we have in the symbolic way right here. A log isolated on one side of the equation. If we look at our equation, we do have a log only on one side. However, it's not isolated because of this 8. So we'll most likely be using this first technique to solve the equation. But let's take a look at the second method just to be sure. With the second method, we're required to have a log with the same base on both sides of the equation. We can see that in our equation we have log only on one side, so we won't be using this second method. So focusing back on the first method, what we're going to do is we're going to convert to an exponential equation using the definition of a logarithm. And then we'll solve the remaining equation by isolating x. But as I said a moment ago, we're required to have our logarithm isolated on one side of the equation. And this 8 does not have our log isolated. So we need to use our properties related to expanding and condensing logarithms to get rid of that 8. And actually we could, since this is multiplication, we can divide both sides by 8 instead of using those properties. So we can write this as natural log of 2x equals 40. Oh, 40 divided by 8 would be 5. So now we have our log isolated on one side of the equation, and now we're going to convert to an exponential. To convert to an exponential, we need to know what base we have on our log. We're using the symbols ln, which stands for natural log, and natural log is having a log with base e, the natural base. So these symbols ln are equivalent to log with base e of 2x equals 5. So using the definition of a logarithm, we'll rewrite this as an exponential. The base of the log is the base of the exponent. The log always equals the exponent, so 5 will be the power. And then this expression equals the expression inside the log, which is 2x. Now that we've converted to an exponential equation, we'll solve for the variable x by dividing both sides by 2. So we have x equals e to the 5th over 2. Then we need to make sure we check. We're going to check our solution of e to the 5th over 2 by substituting into the original equation. E is 2.718. That's a positive number raised to the 5th power. That'll be positive. A positive divided by a positive and then multiplied by a positive will be positive. So since we're taking the log of a positive, we're going to be able to keep this solution, and the only solution to this equation is e to the 5th over 2. On this question, we want to use the change of base formula and a calculator to approximate the following logarithmic expression. Log base 3 of 59. So first of all, we want to know what the change of base formula is. The change of base formula is a formula that allows us to change from any base to any base. And the formula looks like this. You have log base b of m. You can choose to go to any base you want. So I'm going to choose to go to base a. And we're going to use m from the original log. M will go into the log that I have in the numerator. And we're going to use b from the original log, and that will go into the log from the denominator. So this allows us to change from any base to any base. Now typically calculators will have built into them natural logs, which have base e, and common logs, which have base 10. So under most circumstances, when you're using a calculator, you are going to choose to go to either base 10 or base e so that you can use those built-in logs that are in your calculator. So let's use natural log base e. So we're going to start with our log base 3 of 59. I'll go to natural log in the numerator and denominator. 59 goes into the log in the numerator, and 3 goes into the log in the denominator. Now I want to use a calculator to approximate this expression. Use natural log of 59 divided by natural log of 3. And we get that we have an approximation of 3.71. Maybe we'll round to 2 decimal places, 3.712. This calculator is a little bit more advanced. It does have log base 10, the common log built in, and log base e, the natural log built in. And it also has a feature in the calculator being able to type any base. So I thought we'll confirm our answer. We'll go to the math menu. At the bottom of the math menu, we have that built-in function that'll allow me to type any base. We have log base 3 of 59. And you can see we get the same answer using the change of base formula that we did typing the original expression in. So our approximation is 3.712. For this example, we want to evaluate the expression without the use of a calculator. Our expression is natural log the 9th root of e to the 7th. To evaluate this expression without a calculator, I want to remember that a radical can be written as a power. So this is the 9th root. We can write the 9th root as e to the 7/9. And there's a property of logarithms called the power rule. And this property of the power rule allows you to take a power inside of a log and rewrite it as the coefficient or being multiplied by that power. So we're going to be able to write this with the power rule as 7/9 natural log of e. Now, natural log of e is an expression that we can simplify. I'm going to do this work over here on the side to figure out what natural log of e is. So whenever I don't know what a logarithmic expression equals, I'm going to let it equal some value of p. And I chose p for power because logarithms always equal powers or exponents. So to simplify this, I'm going to try rewriting this as an exponential. I know that natural log has a meaning of log with the natural base of e. So the symbols natural log are the same as log base e. Carrying down that e that's inside the log, I get log base e of e equals p. Now that I know what base I'm working with, I can rewrite this as an exponential using the definition of a log. Using the definition, we'll use this base of e. The log always equals the exponent, so p is my exponent, and this expression equals the expression inside the log. So I have e to the power of p equals e. And using my knowledge about exponents, I know that e to the first power will equal e, and that means that p is 1. Back at the beginning, I let p equal my expression, natural log of e. So natural log of e is equal to 1. Now that I know that natural log of e is equal to 1, I can simplify this to be 7/9 times 1, which is 7/9. So I have my expression, natural log of the 9th root of e to the 7th equal to 7/9. Thank you for checking out my videos. Have a great day.